Alright, I wanted to do a quick video about the different financial formulas. One of the challenges that will come on the final exam or on exams in general when you cover these is there's a whole bunch of them, and in your homework you typically use one formula over and over and over again, and then the next section you use a different formula over and over and over again. But on the final exam, you have problems from all these sections, and you have to figure out which of the formulas you use and when you use it. The most common one, well, sort of the base formula is the simple interest formula. S equals P plus PRT, or sometimes you'll see that they'll factor the P out, they'll undistribute that and get S equals P plus PRT. In a simple interest situation, what you have basically is linear growth. What happens at time equals 0 is you put in some money, you make a deposit of some money, and then at some time later, whenever you're tired or you need your money, you take your money out and you give your money back plus a little bit of interest. The interest rate depends upon how long you've been. The amount of interest you get depends upon how much money you put in, the interest rate, and how long you put it in there. But if the rate stays constant, the principal amount never changes over that time, and you end up with just a simple straight line in there. The next one that's a little bit more complicated is compound interest. Again, at time equals 0, you put in some money, it earns interest, but what happens is every so often the bank adds a little bit of interest to that. Let me actually move that graph down a little bit larger. So what we start off with is a dollar amount that you're putting in to start with. After a little bit of time, you get that dollar sign plus some interest. But because the amount of money in the account is actually increased, what you'll end up with is a line that's got a slightly steeper slope for the next month. And so what happens is you earn a little bit more interest the following month because there's more money in the account. With simple interest, they never add the money into the account until the very end. But with compound interest, every so often they add a little bit of money into the account. And so what you get is a curve that, as time goes on, gets steeper and steeper and steeper. It's like all these little straight line segments that keep getting steeper and steeper with the compound interest. And of course, the compound interest formula is P is equal to S is equal to P. S is your account balance. It's equal to the principal times 1 plus the interest rate divided by the number of times that interest is compounded in a year, raised to the total number of compounding periods. So a lot of times we'll say that P is equal to 1 plus R over M raised to the 1 plus R over M raised to the M times T power. When you're doing that on your calculator, you want to be sure to put that, if you're going to do that multiplication, the M times T in a set of parentheses. We don't really need it when we write it out because we write it in superscript that's kind of a little bit smaller. But when you go to type it into your calculator, you want to put that multiplication in parentheses to make sure that that multiplication happens before the exponent part of the calculation goes on. So compound interest, you make one deposit. The bank adds in interest as we go along, and you end up with a fairly big chunk of money and with some interest added on. Especially the longer that you let it go and the better the interest rate you can let it go a long time. With a big interest rate, you get a lot of money that way. But there is just that one deposit. Same with compound interest and simple interest. They have that one deposit. But that's not really what happens in life. Typically, when you're doing a long-term saving plans, you're going to repeatedly put money into an account. If you're saving for your retirement or you're saving up for a big purchase or something like that, you're going to repeatedly put a dollar amount into an account. And so there's two types. We call those annuities when there's a reoccurring payment And there's two types. There's the future value. In the future value annuity, you make initial deposit. It earns a little bit of interest, and then at the end of the next month, you make actually typically what happens is we start at 0, and at the end of the first month you put in your first deposit. That's typically what happens. And then the math is just a little bit easier. The formula is a little bit nicer if you do it that way. At the end of the second month, you've got your first deposit. Your first deposit has earned a little bit of interest, but then you're going to add money to that. So what you do is you get like a linear graph, and then it makes a jump up here to a larger amount. And at the end of the next month, you make another deposit. So there's an extra dollar sign in there and a couple of cents because you've earned interest on those two accounts. And at the end of the next month, you're going to add another dollar amount. You're going to get well, that's not showing very well, but what happens is you get jumps in your graph as it goes up every time you make a deposit. But you accumulate money pretty well in that one as well. It's because you're doing those repeated payments, it's compound interest plus, it's extra sort of thing. And that's the big key with the future value formula, is that you're making repeated payments in there. So anytime you've got repeated payments, either you're depositing every month or every year, you're putting more money into the account, that's going to be an annuity. And a future value, typically you start with nothing and you save up until you have a large amount at the end. You're accumulating money. The formula is the future value is equal to the payment times 1 minus, that's 1 plus r over m raised to the mt power minus 1, and that should be all in a set of parentheses, and then divided again by r over m if you're going to do it all in one calculation in there. That's the way that I like to do it, with a little r over m in there. R is your interest rate, m is the number of times you're compounding in a year, t is the total number of years in there. A lot of textbooks will sort of simplify this formula. They'll make you calculate the r over m first. They'll call it I, and they'll find big N, which is m times t. It's the total number of payments in there. It's the number of payments per year times the number of years, or it's the total number of payments in there. And again, to get this into your calculator correctly, when you write it out by hand, you don't need that extra set of parentheses, but you need an extra set of parentheses around the entire top and an extra set of parentheses around the entire bottom, because you want to do all those calculations on top first before you do the division by the other ones. Whoops, and they're using an I. And actually the I kind of simplifies things a little bit, because the I is just a number. You don't need to put something in there. And a lot of times they'll use R for the payment amount, and S for the account balance. Again, you're looking at the account balance there at S at the end of the time periods. Okay, and you'll see problems where you have to solve for R, or where you have to solve for S, where you want to know how much money you have in the end. R is how much money you have to put aside every month. You'll see some questions that maybe say, how long will it take you to save up to a certain amount? That will be solving for the N in there. And typically when you're solving for the N is up in an exponent. That means you're going to have to use a logarithm at some point when you're solving that equation. All right, the next type of annuity is a future value or present value annuity. In a present value annuity, we start with a really large chunk of money. We start with a large amount of money in our account, lots and lots of money over here typically, and then that account earns a little bit of interest, and then we take out a payment. We're going to drop down our account balance because we're going to take out a payment. We're going to take out a chunk of money. What's left is going to accumulate a little bit of interest in the next month, but then all of a sudden we're going to take out at the end of that month, we're going to remove another payment, and so the balance is going to drop down, and so you get a balance that grows a little because it's earning interest, but then it drops at the end of every month when you take out that payment. And eventually down here, you end up with, as you're taking out those money, you get those dollars, and eventually down here you take out your final payment and you end up with nothing left in the account. So you start off with a whole bunch of money and you take out money out of this account until the end, and you slowly end up with nothing. And the formula for that typically is PV for present value. It's your payment again, times now 1 minus 1 plus R over M to the minus MT. There's an extra negative up in the exponent. And in this case, you subtract in there. You got to subtract 1 minus the R over 1 plus R over M. It's very similar to the present value, future value formula, but they are different, and it's easy to keep them, easy to kind of get those mixed up. Be sure to pay attention to that negative sign in there. And then the, again, a lot of books will have instead S is equal to R times 1 minus 1 plus I to the minus N, capital N, divided by I in there. But you do need an extra set when you're calculating that. You do need to enter a set of parentheses around the entire top in order for your calculator to crunch out that number correctly in there. Again, negative exponent there on the present value annuity. The present value annuity is also the formula that you use for a loan. It's just the same idea, but it's upside down. Instead, you start off, you borrow a whole lot of money. The bank is going to charge you some interest. You're going to go larger in debt, but then your payment is going to reduce what you owe. And then you're going to the bank charges you some interest, so you go a little bit farther in debt, but then you make a payment at the end of the month, and your balance drops, and it kind of goes to the same sort of thing. And eventually down here, you get back, you make that final payment, and you're back to zero, and you've paid off the loan. But it's just a present value annuity turned upside down. Is a loan. It's below the x-axis instead of being above the x-axis. But the concept is exactly the same thing. You've got a large balance that's earning interest, and then you're making payments that are reducing that balance until you finally get to zero. So you got a large amount of money that's earning interest, but your payments are slowly reducing that balance in there. So those are the four main financial formulas that are out there. One other one that kind of comes back in here on compound interest, there's the continuously compound interest. Which is the S is equal to P E to the RT. That if you shorten these long line segments over and over again, the best curve you can get is an exponential function with that funky number E as the base in there. So the three basic interest formulas are the simple interest, the compound interest, and the continuously compound interest. In all three of those, you make an initial deposit at the end. At the beginning, you withdraw the money at the end, and you also get some interest along the way. But it's a one-time deposit, one withdrawal at the end. With the two annuities, with the future value and the present value annuity, you're making repeated payments. You're either adding money into the account at regular intervals, or you're taking money out at regular intervals. And so that's the thing to do, that you're making that balance go down with the present value annuity, you're making the balance go up with a future value annuity. You're saving up money typically with a future value, and a present value you're paying it off. So a future value would be when you're saving for your retirement, when you're putting aside money every month to get up to that dollar amount, or you're saving for a big trip, or you're saving, you're being conscious, putting aside money every month to save up for some big sort of thing. In a present value annuity, you've got a big balance that you're slowly paying off, or you're slowly reducing down. It's like after you retire, or if you receive a trust fund or something like that, a lot of times those will pay down as you go on in there. All right, so I hope this helps. Thanks a lot.